Thermocouples are commonly used temperature-sensing elements in temperature-measuring instruments. They directly measure temperature and convert temperature signals into thermoelectric potential signals, which are then converted into the temperature of the measured medium by electric instruments, secondary instruments. The shapes of various thermocouples usually vary greatly according to the specific requirements, but their basic structures are generally similar. They typically consist of main components such as thermoelements, insulation coverings, protective tubes, and junction boxes, and are commonly used in conjunction with display instruments, recording instruments, and electronic regulators. Thermocouples, known for their wide temperature measurement range, fast response time, high accuracy, and ease of use, have become widely employed temperature sensing elements in various fields including industry, scientific research, medicine, and environmental protection. In this lesson, we will mainly study the definition, working principles, and structure of thermocouples. 1. Firstly, let's learn about the definition of thermocouples. Thermocouples are devices that utilize the thermoelectric effect of conductive or semiconductive materials to convert temperature changes into changes in electromotive force. Nearly 200 years ago, the German physicist Thomas Johann Seebeck discovered and proved that when a closed loop composed of conductors A and B of different materials has different temperatures at its two nodes, an electromotive force will be generated in the loop. This physical phenomenon is called the thermoelectric effect. The closed loop composed of conductors of two different materials is known as a thermocouple. The conductors composing the thermocouple are referred to as thermoelements, and the electromotive force generated by the thermocouple is called thermoelectric force. 2. Next, let's learn about the working principles of thermocouples. The thermoelectric force difference depends on the temperature difference, and the change in temperature difference varies for different metals. The junction with the higher temperature is called the hot junction, or measuring junction, which is placed in the measured medium during temperature measurement. The junction with the lower temperature is called the cold junction, or free end, which serves as the reference junction during temperature measurement. If the temperature of the hot junction needs to be measured, the temperature of the cold junction must be known, and the temperature of the cold junction is measured by other temperature sensors. According to the thermoelectric principle, the temperature of the hot junction can be calculated and determined. According to the theory of thermoelectric force formation, a closed loop composed of conductors of any different materials can form a thermocouple. However, for accurate and reliable temperature measurement, the material selection of thermocouples must be strictly required. Practically used thermocouples should have good linearity and stability, strong interchangeability, fast response, and ease of processing. There are commonly 8 types, such as T-type, E-type, and J-type. 3. Finally, let's learn about the structure of thermocouples. To meet the temperature measurement requirements of different production objects, common structural forms of thermocouples include ordinary thermocouples, armored thermocouples, thin film thermocouples, etc. The first type is the ordinary thermocouple, which is the most widely used in industry. It usually consists of thermoelements along with insulation coverings, protective tubes, and junction boxes. When installed, it can be connected by threads or flanges. According to the usage conditions, it can be made into sealed ordinary type or high-pressure fixed thread type. The second type is the armored thermocouple. The so-called armored thermocouple refers to a thermocouple constructed with a protective armor sleeve similar to armor, filled with protective materials such as magnesium oxide and aluminum oxide between the armored sleeve and the thermocouple wires. This type of thermocouple has good corrosion resistance, oxidation resistance, and vibration resistance. It is widely used in industrial temperature measurement and control systems. The third type is the thin film thermocouple, which is made by vacuum deposition or chemical coating of thermocouple materials on an insulating substrate. Thermocouples can be made very thin, with thickness ranging from 0.01 to 0.1 micrometers, allowing them to measure surface temperature without significantly affecting the temperature variation of the surface being measured. Their small thermal mass and rapid dynamic response make them suitable for measuring temperature changes in small areas and instantaneous variations. In addition, there are surface thermocouples used to measure the surface temperature of arc-shaped solids, immersion thermocouples used to measure the temperature of liquid metals, etc. In this lesson, we mainly studied the definition, working principles, and structure of thermocouples. I believe everyone now has gained a certain understanding and awareness of thermocouples. After class, you can explore the application scenarios of thermocouples and further understand their working principles. That concludes our lesson for today. Thank you all.